Hey guys, I'm Tadas Goberis, lead Gen AI engineer at Trimble. I work in Applied AI division where we build agentic systems, chatbots. We do a lot of evaluations. We also use skills, build skills. I mean, a lot of cool stuff. And today I would like to present the idea which changed how I look at prompt engineering. Later down the line, we'll use that to build offline prompt engineering pipeline, as well as online AI system uh, quality assurance gates. So first of all, I would like to start with a question. Whenever you update a prompt, you add a couple of examples, maybe you change the output. How do you know if your prompt got better? Um, I think most of the time we run a couple of examples. We might show the output to colleague, but in the end, we just ship it and hope for the best. But here's the uncomfortable truth. Looks better isn't a measurement, it's a feeling, and feelings don't catch regressions. This is the state of prompt engineering in a lot of companies nowadays. First of all, we have no regression testing. We have no way of knowing if we broke 5 edge cases which were working previously. Second of all, there is no objective comparison. We know that the version 7 is better than version 6, but what about version 5, 4, 3, 2? I don't know, and probably no one knows. Finally, we are doing hope-driven development. We change something and basically go through the workflow, which is looks good, ship it, hope for the best. This would never fly in a regular software, but for prompts, it's norm. So here's a principle that changes everything. Connect your prompt to a measurable downstream outcome. Main idea here is that prompt is rarely the output of your system. Most of the time it connects into semantic search pipeline, classification engine, maybe some sort of larger agentic workflow. And all of these systems have measurements. So instead of asking, does the output or does the prompt look good, which is basically just a vibe check, we ask, does the system behave better? Once you frame it this way, prompt engineering becomes optimization problem, and optimization problems have solutions. So let's visualize this. Here is the baseline and how prompt engineering looks today. First of all, we have a prompt, we run it through LLM, we get an output, we check it, we tweak it, repeat it, at certain point we decide that it's good enough. The problem, there is no signal. You might be improving your system, you might be making things worse, you might be just running in circles. Now let's look into real system I was working on. I was working on support ticket similarity system. Basically how it works, we get a prompt, we get some ticket data, just Jira ticket summaries, we process, run the prompt and ticket data through the LLM, we get a problem statement. Problem statement is basically just a summary of a ticket. We embed the problem statement, we run the retrieval. Key insight is here is that prompt and problem statement is only part of the bigger system, which is retrieval. And retrieval has a measurement. So like previously, we go from does the problem statement look good to does retrieval find the right matches. To make things measurable, we need a couple of things. First of all, we need a golden data set, which is just a curated test cases where you know the correct answer. So in my case, it was bunch of tickets where we know that whenever we run a similarity search on ticket A, we should be getting ticket B, C, and D back. Second of all, we need a couple of metrics. In our case, we used pretty simple ones. It's a precision, basically how many of retrieved tickets are the expected ones or the correct ones. Recall, how many of all possible correct tickets we managed to fetch. And F1, which is a mean of both of these. So now we have a measurement. Every time we run a prompt, we run our system, we get a result. And we move from guesswork to a data-driven optimization. Yeah, so this is the full picture. This is offline prompt engineering pipeline. Basically how it works, as before, we have a prompt, we have some user data, ticket, attachments, whatever. We run it through LLM, we get a problem statement. We embed the problem statement, we run retrieval, compare retrieval results to the golden data set, we get metrics. Here is where it gets interesting. We collect all the previous prompts, outputs, and all relevant metrics, and do an error analysis. We combine all the metrics and send them to the improver. Improver could be a person, could be an LM. In our case, we used an LM. LM evaluates the patterns, what failed, what improved, what regressed, um, provides fixes, and then we can run the loop once more. As mentioned, this becomes an automated pipeline. This is no longer a guesswork. This is a feedback loop, and system tells us what's broken, and we systematically fix it. Let's dive deeper into error analysis part. So basically, how we do it? We sample 10 random cases where F1 is less than 0.3. Random sampling and a rather large F1 was chosen for a reason. We do random sampling because we never want to solve the same problems, and we want as diverse problem set as possible and diverse combinations of problems as well. And F1 was chosen for a similar reason, to avoid overfitting. So first, we have a generated problem statement. Then we have missed matches, as mentioned. Tickets we did not manage to find. Second of all, we have wrong matches or tickets we found but we should not have. And after going through the problem statements, maybe you already see it. Maybe you need 5 more minutes, maybe 10, maybe 15 or an hour, but sooner or later you will identify the pattern. And LLMs are notoriously good at identifying the patterns. Pattern here is inconsistent terminology. The idea here is that after error analysis, we have explicit problem and data which defines what's need to be solved. So now we no longer ask, please improve and make this prompt or make our system or make output good. But now we ask, please enforce consistent terminology in problems which relate to authentication, or consistent terminology just in general. So next up, we have LM Improver. We pass it a structured context. First of all, we send all error analysis we already talked about. Second of all, we send it a prompt history. Main idea here is that prompt history serves as a roadmap. LM knows that which directions he already explored, which directions managed to improve the performance of the system, which directions regress the performance of the system. It tells LM what we should try again, or maybe what improvements we should no longer do. Third, we have guardrails. In our case, guardrails, I would say, were pretty primitive. First of all, we ask LM to make only small incremental changes. We'd like to build on successful iterations, and we would like to avoid overfitting on provided examples, because our prompt, which will be used for problem statements, should be as generic as possible, and we are not solving only our dataset problems, but we're solving all the problems in our system. So finally, when the LM Improver finishes its work, it provides a structured, traceable output as a sanity check. It contains list of changes, reasoning, and a new prompt. It's used so we can track what's going on and we can interrupt the process as it goes in case we notice that the LM is either going in circles or going not in the direction we want it to. So in our case, we used the retrieval system, but the pattern generalizes far beyond. If you're using classification, maybe accuracy is your thing. For summarization, rule scores, hallucination detection. For agentic system, task completion rate, tool use accuracy, multi-step reasoning success. For code generation, test pass rate. For customer support, CSAT or whatever. The main idea here is that the specific metric doesn't matter. What matters is that we find downstream behavior we care about, we make it measurable, and use the measurement to drive systematic prompt improvement. Up till now, we discussed F1 and recall and basically a standard metrics. But what happens if our problem is, does the response sound helpful? Did the summary catch the key points? There's no way of measuring F1 or recall on these questions. In this case, LM as a judge comes to help. LM as a judge is a pattern, well-established pattern, already used in serious production teams like Anthropic or OpenAI, and they use it as key signal in their quality assurance pipelines. Basically, how it works, first of all, we provide three things to LM, which is output to evaluate. Second, task in which the output was generated. And finally, a grading rubric. Grading rubric is a key here. It defines what good means in our system. Example rubric could contain multiple questions. For example, was the task completed? Did we use the right tools? Did we handle errors gracefully? Did we follow instructions defined in the skill or prompt as instructed? We rate each of the answer from 0 to 1, and now the rubric becomes your metric, the metric which we were looking previously for. Rubric is repeatable, structured, and provides a feedback signal which is scored and can be used for automating the process. So now I wanted to take this one step further. Previously, what we talked about was offline evaluation loop and offline prompt engineering pipeline. When I say offline, I mean that the code and use case which we were designing and running previously runs in your local machine, in notebook or wherever. But the idea that we run the process before we deploy and release the prompt. This is an online production pipeline which is run when the code is already deployed. In the system I work on, we generate AI skills, which are basically just prompt power tools. And we cannot just eyeball them every time a new skill is generated. So before shipping those skills, we need to build multi-gate validation pipeline. Our multi-gate validation pipeline consists of 3 gates. First of all, we have static or structure gate. The main goal of this one is to ensure that our prompt or skill has required fields, follows the schema which our system expects. And this gate basically functions as linting for LM prompt. It's as fast as possible and as deterministic as possible. It's a first line of defense. Second of all, we have execution gate, which basically what it does here, it uses the skill, it runs, installs dependencies, runs the MCP servers. We check if DNS resolves. We try to do a MCP handshake. It's an integration test in a nutshell. Finally, behavioral gate, which is slowest, flakiest, but also I would say most important, because it takes a skill, it generates a set of scenarios in which skill should be invoked, maybe it shouldn't be invoked, maybe a set of adversarial scenarios, and then it runs the skill for those scenarios. Then we have a LM judge with a rubric, which evaluates the results. We evaluate all the same things I mentioned previously. Did the task run to the completion? Did we handle errors gracefully? Did we use and orchestrate tools in the right order? This is the final gate, end-to-end gate. The key here is whenever any of these gates fail, our system does not exit and does not just provide an error to the user. We run auto healing loop. What happens there, whenever gate fails, we provide inputs, outputs, all errors to collect all the inputs, outputs, and errors and provide to LM so he can make a targeted fix. After the fix is made, we run the prompt through the same gates and we try to revalidate. This loop is run up to 3 times, and we also have a certain budget cap, so we don't just loop infinitely and consume all our monthly wages in here. So the key idea is that we follow the same pattern as previously. First of all, we identified a certain metric, we try to measure it against it, then we collect the failures, try to fix our system, and then we revalidate again. It's a fixed loop just run in a production. Main idea here is to present a pattern in the production, and in case you need to ensure production system stability, that's also a thing you can implement. So I wanted to be honest about limitations, because the pattern does not work for everything. If you can define what success looks like, even roughly, if you can write rubric, task completion, instruction following, or even tool usage, these seem like a subjective problems in a traditional sense, but these can be really easily be evaluated with rubric. The problem comes when you have artistic output or creative output, for example, marketing content. There is no way to evaluate good marketing content with any sort of rubric. Another thing is if your ground truth changes rapidly, then it's really hard or even impossible to keep our golden data set updated. Finally, there is a high labeling cost. If your problem your problem requires really deep domain expertise, which might be real expensive, then setting up a golden dataset might be real expensive and not feasible for the company as well. But for the vast majority of prompts, I think prompts and systems, I think these 3 cases are really edge, and most problems can be solved by either evaluating downstream metrics or building structured evaluation rubrics. So this is what I want you to take away from this. Art of prompt engineering becomes software engineering when you have evaluation. We have known for decades that software without test is fragile. You cannot refactor confidently, and you're always one step away from breaking production. Prompts are the same. Without measurements, you're flying blind. The good news are that you have more tool than maybe you think about. You can always have a downstream signal coming from your system. You can and you can use those metrics directly. You can set up a structured rubric with LM judge, and whenever you need production time guarantees, you can build evaluation gates. So here is a little homework for you guys. First of all, look into your system and identify the most sensitive prompt. Then decide which part could function as a downstream signal. If there are no downstream signal, set up a structured evaluation rubric. Then build a golden dataset. Golden dataset does not have to be big for starters. 20 use cases is a very good starting point. Then you can close the feedback loop as previously. We want metric, we want to evaluate on that metric, we want to collect errors, and then when we have collected errors, we can make fixes and then reiterate once more. Finally, whenever your system matures and is ready for it, you can set up application production time guarantees with application quality ensuring gates. Once you do all of this, I say that you pretty much can stop guessing and start engineering. So that's basically the pattern I wanted to show you. I already heard that this is not the time for questions, and most of the questions are either in Discord or after the talk is completed, so we can move those there. Thanks.